Here's another problem, one that we can actually do here. It's just two balls sitting inside a container right now, and it says find the force that the container exerts on the marbles at points A and B and C, and then the forces in between the two. The reason it's set up that way, let me point out that in a statics problem like this, you can take whatever physical system you want to. If I take the two marbles as my single physical system, then I don't have to worry about forces in between those two marbles. I only have to worry about external forces. So if I take that marble and that marble as my physical system, which I can do, then I know that at point C, these are round and you can ignore friction forces. So this force, that force at point C is going to be to the left. From the geometry of this, I can figure out the height. I know the diameter of the container. I know the sizes of these marbles. So I can figure out the height of point C. There's different ways of thinking about this, but at point A, you know you're going to need same force, bigger force, smaller force? Think about the net force on that physical system. Are there any other horizontal forces on that physical system? Yes. There's that. There's a normal force at point B, pushing up. The Earth is pulling straight down. Strictly speaking, the Earth is pulling straight down at the center of mass. You don't have to do it this way. You could take a force down at the center of mass for that one. That's half the force because it's one of the marbles, and another force down there as the other one. But I just wanted to be tricky here and say that since we call that the physical system, the center of mass is in between the two, and the force by the Earth can be thought of as just acting in that one place.
If they're different systems, then you have another horizontal force.
If they're different systems, then I have that upper one pushing on that one, and Earth pulling down, and that to the right. So then I have FA still there, same FA, same FB, different force by the Earth because I've only got half the marble. So not as big a force as this one, because this is the force by the Earth on the system of two marbles. And the net force there has to be 0, and the net torque has to be 0. For this one, as one system, this has F top marble on bottom. Lots of times you want to know something like that. It isn't just because there are two separate objects. Sometimes you have a single object. I'm holding this right here. The right-hand side of that object is being held up by the left-hand side. So all the forces that hold up the right-hand side are applied by the left-hand side. The left-hand side has a bunch of chemical bonds, and it is pulling and holding up the right-hand side. So it isn't just because two things are physically different, that you think of them as different. Anytime you want to know about forces inside some object, chop it in half just in your mind and think about the right half. Because whatever it takes to hold the right half up like that is what the left half is doing. So FC has to be FA because there are no other horizontal forces.
But doesn't it matter then what pivot you choose? Because if you choose it at where FB is working, then wouldn't FA have to be a much larger force because the moment arm is smaller?
Well, but you got the force by the earth.
That's true.
So I would choose, one thing you could choose is that point. Take that as a pivot point, and then you don't have to worry about FA or FB. They both go right through that pivot point, and neither of them produces a torque. So then you have a counterclockwise torque due to FC, and a clockwise torque due to the force by the earth. This is the R perp for FC. And this is R perp for the force by the earth, the weight of the tube. And those torques have to cancel. And so since they give you the weight and you know all the geometry, you can get all the R's. And from that right there, that one torque equation where this is the pivot point, you can find out how big FC is. And then you can find out how big FA is, because it's the same as FC. FB, of course, has to be the force by the earth. So now you have all of those forces. And once you know FB, FA, force by the earth, then you can also automatically find the force by the second one on the first one, just by thinking of the lower one as your physical system. So you can do the whole thing together and then take it apart to find out what the internal forces are like. In fact, that's the standard way you would probably do it. Do the whole structure first, figure out what the external forces on the whole structure are like, and then start breaking it up into pieces and find out the forces on the internal parts. So I have a question for you. Suppose we cut the bottom off of this thing, because I will. This doesn't have a bottom. I'm going to drop this one in first, and then I'm going to drop that one in. This is a big heavy steel one because I wanted a big force here. And I want you to think about the question of the torques and the forces of these came up. Think about this situation. Think about forces on this thing right here. And tell me if the tube is just going to sit there. Thank you. Is the tube just going to sit there? Is it going to tilt over to the right? Is it going to tilt to the left? Or who knows? I'll remind you I'm putting the big heavy steel one up on the top here. What do you think?
I think it's too high.
Since we're talking about the aluminum tube, just think of the aluminum tube and the forces on the aluminum tube. It's aluminum, so there will be a downward force by the earth, but aluminum is not very big compared to a big chunk of steel, not very heavy. So I'm going to take this off in a second, and then it will just look like that. Depends on the mass of the can, and it depends on the mass of the can relative to the balls. But the top ball is by far the most massive thing. So
Well, when we're looking at this, we're saying that it's going to be whatever the distance is. When we say tilt to the right, towards the big
tilt to the right means clockwise rotation.
of the picture, not of the real.
Of the picture. So to the right means, well, the upper one is to the right of the lower one. Is another way to say the same thing. Here.
Yeah, it's,
So, yeah, but that doesn't matter, it turns out. Something has to be, something, the upper ball is the thing that's going to be count, or the whole thing. I've made the whole thing massive by putting a lid on it. I've artificially made the aluminum massive by putting something heavy on top of it. But I'm going to stop it now. Let's see where. Oh, come on. That's great. It worked a second ago.
See, it tilts a little. It works.
It really wanted to, and I swear it was easy earlier.
so it's in the physics building. Where?
Yeah, go in the physics building, main door, past the elevator. The first door on the right is the mailbox, the mailroom.
Right past the elevators, first floor on the right.
Yeah, past the elevator, first door on the right, mailroom, my box. Yes, my name. Yeah, it's underneath my box.
All right, thank you so much.
It almost didn't tilt over. It
Almost.
barely tilted over. Why is that?
Sometimes we leave it sitting up.
Anyway, it did tilt over.
Yeah.
I just waited, and it kind of rolled around, and it moved around, and finally it tilted over.
Yeah, if you let it sit long enough for some reason, it will. I'm not sure if it's settling in or maybe the